in this video, we're going to discuss what it means to factor something completely. So in our introduction to factoring video, we talked about these 3 steps that we have to do every time we factor. Whenever we're presented with a polynomial, we need to run through these 3 steps to decide how we're going to factor and what we're going to do. So when we're going to complete this factoring, we need to look for 3 things. First, I want to look for the greatest common factor. So let's work through this with this polynomial. 5x cubed plus 15x squared plus 10x. So as I'm presented with this polynomial, the very first thing I want to do is see, are there any greatest common factors that I can pull out of all the terms in my polynomial? In this case, there is. There is a factor that goes into all 3 of these terms, and that factor is 5x. So I can factor out that 5x, and I see that I'm left with x squared plus 3x plus 2. Now, I have split this up. I factored it out. Now, when we come to this next step called where we say we count terms, what I want to focus on is I want to focus on this polynomial or the terms of our polynomial. If I have a monomial, like I do here, that's already factored enough. That can't be simplified down anymore. So I don't need to worry about it. Then I'm going to look at any other polynomials I have. Here I have this other polynomial, x squared plus 3x plus 2. Now with this polynomial, I need to see how many terms it has. And depending on how many terms, that's how I'm going to decide what I'm going to do to factor it. If I have 2 terms, then I have to use one of those special products, one of those special product patterns. Remember, that's like the difference of squares. At some point, we'll talk about the difference of cubes, things like that. That's that special products pattern. We have to use that when we only have 2 terms. This next case, when we have 3 terms or a trinomial, we are going to use that x method. So remember, the x method is where we multiply our a times c on the top, add to the b on the bottom. We get these, and then we're going to divide by a to whatever we get inside. We had a couple videos practicing it, sometimes where we had an a, or sometimes where a equaled 1. Lastly, if I have 4 terms, that's when we're going to do that grouping method. And remember, the grouping method is the one where I group up part of the terms and then factor out what's inside. The last thing we have to do, and what we're going to kind of talk about today, is this 3rd step where it says factor completely. So a lot of the time we'll do part of it, but people don't finish out that factoring. So what we're going to practice in this video is looking at a polynomial, deciding, is there a greatest common factor I can pull out? What method should I use? And then applying that method and factoring it out until it's in its simplest form possible. So let's take a look at a couple of examples, practice this so we get into that habit. Now, let's take a look here at this first one. And these say how we're going to do it. I don't want to do it that way. I want to look at what happens. So let's look right here at part A. I want to ask myself, first, do I have a greatest common factor? Well, I have x is here, x is here, x is here, but no x's in that term. I have a 3 in this one and in that one, but not in the others. There is no greatest common factor. This is it. The second thing I need to do is count my terms. I'm going to count my terms. And I'm going to count 1, 2, 3, 4. I have 4 terms. So 4 terms means I'm going to factor with grouping. So let's do that. Factor with grouping. And then we want to make sure that we factor it completely. So I'm going to factor with grouping here. I'm going to put in my grouping symbols. I'm going to rewrite it. X cubed plus 3x squared plus negative x minus 3. I'm going to factor out what's in common, my x squared, and I get x plus 3 plus, I want an x plus 3 over here, so I'm going to factor out a negative 1. And then I factor out this x plus 3. So a lot of people, when I talk about factoring completely, some people will stop right here. We need to go on and finish that last step. So I have an x plus 3 here and an x plus 3 here. So what I end up doing is I have an x plus 3 that I factor out, and what's left over is this x squared minus 1. Now wait. This x plus 3, that works. Each of these are an individual, but I want you to look right here at this term. I have an x squared minus 1. So right here, I have my greatest common factor, it's done. I've counted my terms. I have a binomial, but does it follow any of my patterns? No. So this is factored. If I have just an x plus something or an x minus something, that's factored. But I want you to take a look at this x squared minus 1. Can I factor x squared minus 1 down anymore? Well, this looks just like our difference of squares there. This looks just like that difference of squares. You know, the one that says a squared minus b squared? Because this is x times x, and this is 1 times 1. So I can actually factor this out even more. I have an x plus 3 times, remember this factors out with that difference of squares, x plus 1 times x minus 1. Now, when we're looking at those, that's what we want to see. Now, the time when we're not going to factor something like this out is when I have an x squared plus some number. This we call prime. We cannot factor that using the x method, using a difference of squares, because we're adding it. The only solutions here are going to be in the imaginary numbers. So because of that, we will learn how to factor that in chapter 4. But until then, we're just going to say it's prime and leave it at that. So look at that. I factored that out completely. So once I get to this step and I factor it, the third thing I need to do is check, can anything else be factored? And usually it has to have an x squared, it has to have an x cubed, something like that to break it down again. So let's take a look at this next one, run through our 3 things again. Greatest common factor. There is no greatest common factor here. So count my terms, 1, 2, 3, 4. I have 4 terms. That means I'm going to do grouping. So group this, group that. What happened? I end up with an x squared plus y times x plus xy. I can't factor anything out here, but I can factor out an x here. But does that seem to help me? No. So when we talk about grouping, during class we talked about always grouping the first 2 together. However, we can adjust what we're grouping based on the problem, because remember, addition is commutative, so I can rearrange these. So here I'm going to put all of the x's next to each other. I've got x squared plus xy plus x plus y. I'm going to rearrange it. Now I'm going to group again. And the reason why is I noticed I have an x and a y, but in these terms, they both have an x, and this one will have a leftover x, and this one will have a leftover y. So when I go to factor, I can factor an x out of this one and get an x plus y. And I can factor a 1 out of this one and get that x plus y. And notice, now I have 2 terms that are the same. So I can simplify this, and I get x plus y times x plus 1. Now, is there a greatest common factor here? The greatest common factor is 1, so we're good. There are 2 terms. Can I use any of my special products here? No, I cannot. So that's as simple, that is as factors as it's going to get. Same with this other term. So this is how we have it factored out completely. So let's take a look at these next 2 examples. We're going to do those same things again. Remember, our rules here are our greatest common factor, count your terms, and then can I factor anything else? Can I factor more? So let's take a look here at this first one. I'm going to factor out, I have a 3x, and that's going to leave me with an x squared minus 4. This is a monomial, so it doesn't factor anymore. But this next term, I have 2 terms here, and what can I do with 2 terms? Well, that looks like it follows my special product property. And so what that's going to do is I end up with 3x times x plus 2 times x minus 2. Now notice how the degree on these are 1. If my degree is 1, then it's as simplified as it's going to get. And that is factored out all the way. Let's take a look at this next one. Greatest common factor. Hey, look, all of these exponents here, they have a 2, and they also all have a y. So I can factor a 2y out of each of these terms. 2y. What's left here is a y squared. What's left here is a negative 6y. And what's left here is a plus 9. Now, this term right here, it's factored out. It's a monomial. It is what it is. Now I have a trinomial. And remember, with a trinomial, we are going to use our x method. So I want 2 numbers that multiply to 9 and add to negative 6. So what numbers are factors of 9? I've got 1 and 9. I've got 3 and 3. I've also got -1 and -9 and -3 and -3. So this will be a -3 and -3. So it factors out into 2y times y minus 3 times a y minus 3. Now notice I have a monomial, I have a degree 1, a degree 1, a degree 0, degree 0. That is as simple as we're going to get. So every time we want to factor out these polynomials completely, I'm going to factor out that greatest common factor. I'm going to count my terms, see, can I factor with a special product pattern? Can I factor with my X method? Once I've factored it, is there anything else that I can factor? Or is everything here either prime, meaning that it's an x squared plus some number? It is a monomial, or it's got a degree of 1. If one of those cases is true for our polynomials, then we know that that is factored completely. So as you finish and you prepare for your test, make sure that you are following these 3 steps. Count your terms, find your greatest common factor. Once you factor that out, count the terms. Which method are we going to use? The special product patterns, the X method, or factor by grouping? Once we've done those things, look at what we have after we factored the first time. Is there anything else that can be factored? Remember, the things that cannot be factored are going to be something that's prime. So that means it's going to be like an x squared plus something else squared. It's going to be option number 2 is it's a monomial. Or option number 3, it has a degree of 1 for our polynomial. If it's one of those 3 things, we cannot factor it any further. Good luck. If you have questions, feel free to reach out.